Assalamualaikum, and good day everyone. So in this topic we will cover chapter 3 on process. So in this topic we'll cover several subtopic on process, which include the concept of process, the scheduling, the operation, inter-process communication, and lastly the communication if we have the client-server system. Now this is the objective of this topic. We start with the term process, the definition of a process, and next features on process, and after that exploring inter-process communication, and the last one is the communication for client server. Now let's start with the concept, process concept. So in any operating system there are a variety of program that are being executed. One option is a batch system, or we can also call it jobs, and the second one is time share system. So this is better known as a user program or task. For the textbook that we use for this course, job or process means the same thing. So what is a process? By definition, process is simply the executing program. It means, for example, when you write your program, when it is not running in stay as a file, so it is a passive entity. But when you run the program, then that program changes its state from passive entity to running program. Then that running program, we call it process. Now process is active entity. So that is the difference between the program and process. When the program stay in a passive state, we call it program. Normally it is stored in your hard disk or any other storage device. But when it is running, we call it process. So process is active entity. So it can only become active when the executable file is now loaded into a memory. So it can only be executed once it is loaded in the memory. If it stay in the storage, still in the storage, it is still a passive entity. There are many ways to execute a program. Of course, the most common nowadays through mouse click. If the GUI is available in the operating system, then you can use mouse to start the program. So of course, another option is through command line. So normally you can type in the program name and press enter using your keyboard. Then you can run the program. Take note also that one single program can become several process. For example, if many users try to execute the same program, then the same program can become several process. And then in the case of browser program, normally browser require several process running at the same time. Process, since it is an active entity, it require resources, several resources, in order for it to complete its task. One type of resources is CPU. Others, memory, I/O, files, and of course the data. Then once the process is terminated, then there are steps required so that the resources that you assign to the terminated process can be reused by other coming process. For process with single thread, normally it come with one program counter. This program counter is where the next instruction is located. So process, in the process, the execution of process, the instruction is actually executed in sequential order, one at a time, until the completion. That means any instruction executed by a process executed in sequential order, one by one. And for single threaded, the instruction can be executed one at a time. In contrast, for multi-threaded process, one program, it needs one program counter per thread. So this is the case where process consists of more than one thread. So each thread will have their own program counter. Nowadays, in any typical system, normally it allow many process running concurrently. So this is where multiplexing of CPU among the processes is required. Once it involves concurrency, that means the system allow many processes running concurrently. And in many typical system nowadays, the hardware consists of more than one CPU. Now, in managing process activity, it will involve several activity that include creating and deleting the process, suspending and resuming the process, handling process synchronization and communication, and also handling deadlock. Now, process in memory. So it consists of several sections. The process in memory means the running process that is active. Remember, the process, in order for it to be active, it must be loaded in the memory. So once it is in the memory, it consists of several components. So the first component is text, the data, the heap, and the stack. Text is where the program code is located. Data is the data that you are going to manipulate by the instruction you put in the text section. And heap is where the memory is dynamically allocated. Stack is where in your program you store when you declare a function and the parameter, the variable, that is normally stored in a stack. Now of these four section, heap and stack can be dynamically allocated. That means they can grow during the running or during the execution of the process. Whereas text and data, this is fixed in size, but heap and stack, they can grow during the execution of the process. So depending on the requirement of the process, the heap can grow and stack also can grow. Now when the process is running or active, it can be in various steps. Initially process is in a new state, so this is when the process is being created. When it is currently running, then it is in a running state. The process can also be in a waiting state. That means the process is waiting for some event to occur. The process can also in a ready state. So that means normally this is the process is put in a queue, and lastly the process can be in a terminated process. That means the process is finished its task. So this is the diagram of process state. Initially it is in a new state, and it can switch to ready state, and then from ready state it can be in a running state depending on the event that occurring during the execution of the process. It can switch to ready state or in the waiting state, and this loop continues until certain event occur that require the process to be terminated. Then it changes its state to terminated. Once it is terminated, the resources that being allocated to this process can be need to be reclaimed so that it can be used by other process. Process control block. This is where information about the process is stored. So what are the information you can store in the process control block? The first one, of course, is the process state. Just now, process state can be either in new, ready, running, waiting, or terminated. The next one is the program process number, and next is the program counter. Okay, program counter is the location for the next next instruction to execute, and it also have a list of registers that store the data or yes the value of the variable that can be manipulated by the process. It also need to know CPU scheduling and also the accounting information. This is where you can use this information to know the CPU being used, the elapsed time, and also IO information. So this is some of the information that can be obtained from the PCB. a very important aspect in process management. By default, process has one single thread for execution, but you can also have a process that consists of multiple threads, especially when it comes to multiple program running concurrently. So for this one, you need a multi-thread execution. So thread is a very important concept. You can have a process with a single thread that is easy to handle, but you can also, if you want the program to be more responsive, then you can have a process that can run multiple thread, so that process can be more responsive. So because it will allow the user to carry out multitasking from a single one process by creating multiple thread or associated multiple thread for a single process, so that you can execute multiple tasks at the same time. So this is how process is represented. This is in Linux system. You can use the C structure, task struct, to get the information about any process. Okay, another subtopic in process is process scheduling. This is also a very important concept in process management. Okay, since the main goal of process management is actually to maximize the use of CPU, so this can be done especially in a multi-programming environment by doing what we call switching process through time sharing mechanism. So by switching process onto the CPU, you can achieve what we call multi-programming, that allow many program or many process to run at the same time. So to allow that, you need process scheduler, so that this scheduler can be used to select among the available processor which one should be executed on the CPU, because you have a limited number of CPU, especially for a system with a single CPU. So you need to do the scheduling in order for any process to be executed. So the scheduling involve queue. So there are several type of queue. The first one is job queue. This is where all the process in the system is located, and then you have the ready queue, and also the last one is device queue. This is the list of waiting I/O device. The process can migrate among these three queue. The process can be in the job queue views, and then you can enter the ready queue, and next you can also enter the device queue, depending on the state of the queue or the state of the process. How it is implemented? It is implemented using data structure linked list. So you can use the linked list to point to the several PCB, because each PCB here represent one process. For example, you have PCB 7 and PCB 2 pointed by the ready queue. So each PCB represent one process. So how to represent process scheduling? So it can be shown as a diagram. For example, over here you have the ready queue. That one is ready to be a list of process ready to be put or sent to the CPU, depending on the current state of the running program. Okay, when it comes to scheduler, there are two types of scheduler. The first one is short-term scheduler. So this is the scheduler or CPU. This is involved CPU scheduler. So its role is to select process that need to be executed, and because any process to be executed, it needs a CPU. So this role is played by CPU scheduler. So this is called short term because it is invoked many times. Normally in terms of millisecond. That means CPU scheduler invoke a very fast process. And another type of scheduler is long-term scheduler. This one is invoked infrequently in terms of seconds and minutes, considered slow. So normally it is for job scheduler. Now the process itself can be categorized into two types of process. Either it is I/O bound process or CPU bound process. Basically, I/O bound process is a process that require or doing a lot of I/O compared to computation. In contrast, CPU bound process involve a lot of many computation compared to I/O. So that means CPU bound process spend most of the time doing the computation. So whereas for I/O bound process, most of it are spent to do the I/O. For example, getting data from the input device, or generating data, or storing data to output devices. So that is I/O bound process. Whereas for CPU bound process, most of its time are doing computation. That means it requires a long CPU burst. Means CPU is required most of the time. So the long-term scheduler need to know a good process mix, because the main idea here is to maximize the usage of the CPU. You want to maximize the utilization of the CPU. You don't want the CPU to be in idle state for longer. There are also what we call medium-term scheduler, but this one involve swapping. That means the process can be stored. If it is not in a running state, it can be stored on a disk, and then when it is ready for execution, then it can be bring back to the memory to be run. In a mobile system, normally it comes with multitasking capability. Normally, for mobile system, you can only have a single foreground processor, but you can have many background process running in the background. So foreground process, because of the limitation of the user interface, normally you can only have single foreground processor. Although at the same time you can run many process, but you can only control one process. Unlike a common PC, you have a bigger monitor, for example, or a bigger display, you can put many programs side by side. But for mobile system, normally you only have single processor. It's a foreground process. Context switch. This is another concept that is very important in process management. So basically, here is context switch involve saving the state of the current state of the process and restoring the state once you need to resume the operation. So the idea of context switching is actually you want to allow the CPU to switch from other process to another process. So before CPU switch to another process, the current process must be saved. We refer to the old process. All process must be saved so that you can restore it again once it is needed to be executed again. So and this is what context switch is all about. The idea is once the OS implement or have the capability of context switch, it allow many programs to run concurrently by simply applying context switch. It seems to the end user that the OS is capable of executing many process at the same time. This can be done because of the context switch. One disadvantage of context switch, it involves overhead, because in order for the context switch to happen, it involves the step to save the old process and loading the new process. So this require a certain step, and it involves it needs to spend some time to do the process, the stage of saving the old process and loading the new process. So when it happens too many times, then it will involve certain amount of overhead. especially in terms of time. Although context switching happen very fast, but still it needs requires certain amount of time. So context switch is very important in order for the OS or for your system to have the capability of running or executing many process concurrently. So this is how the mechanism of how the CPU switch from one process to the other process. So it involves saving the state of the old process and to load the state of another process. So in here, this diagram demonstrates the switching from process 0 to process 1. While you should notice here, when this happen, the CPU is idle, because saving and reloading will involve memory only. There is no CPU. A CPU is not involved. So during this switching, the CPU become idle. So remember, we want to maximize the utilization of CPU. Okay. So that means there is a trade-off of allowing multitasking, and at the same time, during the CPU switching or context switch, the CPU becomes idle. This is an example of multi-process architecture. For example, in a Chrome browser, you can have multi-process, 3 different process for Chrome browser. So you have the browser to manage the user interface. You have the process renderer process to render the HTML, and you can also have a plugin process for various type of plugin supported by the browser. So that means you have one program running, but you can have 3 different processes for that particular program.